Welcome to this exercise on solving fractional equations. Here we have the following equation, which we should solve for the variable x. It's a fractional equation because the x variable we are looking for is situated in the denominator of a fraction. In the numerator, it wouldn't actually pose this much of a problem, but if it's in the denominator, we have to take specific care about it. Well, what am I going to do if I have x in the denominator of a function? Well, I have to get rid of those fractional expressions part by part or step by step. So here I have the big advantage because in both fractional terms, I have the same denominator. So once I multiply this equation with the denominator, I will have gotten rid of both of the two fractional parts at the same time. So multiply this equation with 2 minus x. Then I have to multiply this part with 2 minus x, this one, and that one. So for this one, as I said, this one and the denominator cancel each other out. I'm just left with the denominator of 3 plus x. Then I have minus x times this, I leave standing here. And here I have 1 times 2 minus x, this part. Here again, I multiply this fraction with 2 minus x. This one and the denominator cancel each other out, leaving me with the 2. So then I can get rid of my parentheses, looking like this, and summarize all of this. Here I need to consider that this term has the highest exponent, so I have a quadratic equation. So, well, what do I do in this case? I'm trying to summarize all these values in a way that I have on all of them on one side of the equation, 0 on the other, and in a way that ideally this x squared has a positive coefficient. Well, in this case, we can just leave it on the left side and bring these parts to the left side. So we go with minus 4 plus x. And in the end, we will get this as a result, which is actually a quite easy quadratic equation because we can bring 1 to the right side. And we have x squared equal to 1. And then take the square root of this, giving me two solutions, x being equal to 1 or x being equal to minus 1. Well, in this case, two solutions. But I have to check whether those solutions are actually feasible. What do I mean by feasibility? Well, I'm not allowed to divide by 0. So I have to check if when I insert these two values into this equation, the denominators would get to 0. Well, I can either insert both of them or I take a critical look at the denominators and I see they only get to 0 if x would be 2. Since none of the two solutions is 2, I can rest assured that those two are actually feasible and I will be able to insert both of those solutions into the equation. So here I have found two feasible solutions for my initial equation. Concluding this exercise, bringing me to its end so that I can say goodbye and see you next time.